All right. Welcome to Let's Talk Space Medicine. I'm your host, Kyle Anderson. And for today's show, we have our special guest, Anna Wadhwa. She is a MD PhD student at Harvard and MIT, previously worked at NASA, and is interested in all things human space flight. And I've met her a couple times at a couple conferences, but it's my first time to really sit down and talk to her about all the things that make her such a wonderful person. Thanks for coming on the show, and let's get started.
Thanks for having me. I'm excited to be here.
So this is Let's Talk Space Medicine, where we talk about all things space medicine.
Mhm.
We call these orbits, where we usually do them in about 90 minutes. Just a casual conversation where we get to meet each other and kind of make the world of space medicine a little bit more approachable for people that want to get involved.
Yeah,
So to
absolutely.
get started, how did you first get involved in space med, and when did you first learn about it?
Yeah, I love getting asked that question because I feel like everybody I talk to in the field has taken such a scenic, circuitous route to getting to where we are now. Personally, I was in undergrad. I didn't know anything about space medicine. I was just a normal pre-med kid, doing all of my pre-med requirements, right? Volunteering, shadowing, research, etc. One time I was shadowing in the emergency department, and the physician I was working with, or the physician I was shadowing rather, he sort of turns to me and he was like, "Hey, do you want to learn about space medicine?" And it totally turns out, by happenstance that he was aerospace medicine certified. And so he told me a lot about the work that he does with NASA in terms of the exploration medical capability, XMC, um, sort of platform or system that they're developing. And sort of for the first time in my life, I was sitting there and I was thinking, wow, in 20 years, how do I get your job? It really felt like things sort of shifted, and I was like, this is the coolest thing in the world. This is what I'm meant to do. Um, so from there, he, told me about NASA internships in space medicine. I totally thought you have to be a rocket scientist to work at NASA, which thankfully is not the case. So I applied for those. I ended up taking a gap year in between undergrad and medical school, to work at NASA. I did a couple different internships at Ames Research Center, Johnson Spacer, Goddard Institute for Space Studies, just getting my feet wet in a lot of different fields. Um, and now I'm here at the Harvard program, continuing to research in space physiology. So I'm so thankful that, I met that physician and he really just changed the trajectory of my life.
Yeah, it's so funny. Usually, almost everyone I've talked to has had a similar story where it's by chance someone
Yeah.
just brought it up and then connected the two dots, and all of a sudden it feels like the world's opening up, and you're like, oh my God, what? Like you can do that? You don't have to be a rocket scientist. I mean, it just kind of the stars align, for lack of a better phrase, and I feel like everyone has had that kind of moment. And so this podcast is a way for people to hopefully stumble across it and then be like, oh, this thing exists. I want to do that because I don't know about you, but it feels like we need more people to be involved in every different specialty to address the problems, to get us to Mars, to stay on the moon, all that kind of stuff. So it feels very, very, I'm so happy that that person told you about it and that you're here today on your space med journey.
Yeah. You know, after a while, after I ended up pursuing those internships, we sort of fell out of touch. And years later, I was thinking, wow, I've got to like tell him what an impact he made on my life. And so, but I never, got around to sending that email or, making that connection again until this summer. So I guess 4 years later, I ran into him at the ISS conference, International Space Station Research and Development Conference, because it was in Boston. They had like a free student day, so I signed up to go, and he was there, and I totally fangirled. I was like, "You changed my life. We have to get a picture."
That's so
I think he
amazing.
was
That's
a little,
awesome.
yeah, he was a little surprised to have, a seemingly random med student come up to
Yeah.
him and wow.
Yeah, I mean, it could be like maybe overwhelming, but if I think about it, like, if you're like when you're in your career, like 20, 30 years from now, like just completely established and all this amazing work, which you've already done, by the way, and a med student comes up to you and says, "You changed my life," like how cool is that?
Yeah, right?
Right?
Isn't that like the impact that all of us kind of want to have, kind of inspiring the next generation, enabling that to continue. That's the goal. That's the goal.
Yeah. Yeah,
Oh,
so we recently were physically in the same building and we didn't meet up. I'm sorry, I was only there for one day, but I was talking about the Human Research Program Investigators Workshop. I caught your lecture, your beautiful, wonderful lecture about partial gravity and bone, uh, mainly the genetics component. I believe you looked at expression analysis and different forms of gravity. So you did like no gravity, lunar, Martian, and 1G. And I remember your beautiful slides showing that there was like over 1,000 upregulated,
yeah.
downregulated genes. And then as you kind of went down to, or went up to 1G, a lot of those kind of went away, but they didn't get exactly to zero, which was
No, not
interesting.
exactly zero. Yeah.
So I guess if you want to talk about that, I'd be curious. Is that so? You compare these are animals that went to the International Space Station for, I would guess, about 6 months,
30 days. 30
30
days.
days. Okay, and so they're in these rotating habitats,
It was the
and
coolest
if you
ever.
spin them faster, it gets more gravity, relative gravity, and then if you spin them slower, or don't spin them at all. They experience different forms of gravity. They're singly housed, I believe, and essentially did a lot of the expression analysis, which was if you did that by yourself and like just it
No,
was like
definitely not. Oh my gosh. I mean, what research effort is a solo effort these
not
days?
none of it, none of it at
Yeah,
all.
that was such a cool project to work on. It was called the MHU-8 mission. It was with both NASA and JAXA, which is the Japan Aerospace Exploration Agency, and they had that rotating sort of centrifuging hardware that they developed. And they have capabilities to spin animals up to like 2G. We didn't do 2G, but they have that, and that's sounds like oh, I don't know. I wonder if that's a little uncomfortable. Um, but I think it'd be fun. I think to be a rodent experiencing that if you know what's going on. But yeah, so that was a really cool project. They were up there for 30 days, and then we got them back, and people looked at this was a really big, research team looking at all sorts of expression analysis. Like some people were looking at the brain, some people were looking at the intestines, like the gut microbiome. Some people were looking at the muscles. Our team was looking at the bones, the skeletal system. Was was there, a dose response between gravity versus bone loss in space? Is artificial gravity going to be a viable countermeasure for long duration space exploration missions? Right. We know companies like Vast are trying to develop that and make it a reality with their Haven space stations. So I'm super excited to see what comes out of Vast. But essentially, we basically saw that we looked at one third G or 0G, one third G, two third G, and 1G. And we didn't find a dose response, which was really interesting because you'd kind of expect it, right? You'd kind of expect there to be this like almost linear, maybe there's like some kind of threshold beyond which um, lunar or reduced gravity isn't that bad. But we didn't see that. We really saw that these rodents needed 1G to have comparable bone health compared to our ground controls here on Earth. And that was true for bone structure, bone strength, the gene expression as well. Whereas, for example, our muscle collaborators felt that based on their data, two-thirds G was a sufficient countermeasure or, a sufficient threshold to prevent muscle loss. So that, always has me thinking about like who is going to be making those ultimate decisions, right? It's not going to be just a muscle person that's making that decision. It's not going to be just a bone person, but getting everybody in the same room and talking about that, getting all those stakeholders, if you will, in the same room and talking about what is an acceptable gravity threshold, how can we best mitigate health detriments that happen in space because they're really real. They're a big problem, and we need to get better at mitigating them if we really want to make long duration exploration a reality.
Yeah, I think you bring up an interesting point, like where engineering meets medicine, and it's like, can we engineer a spacecraft to overcome all health problems? Like, if we had a magic wand, of course we would want that, right? Of
Yeah.
course we would want a infinitely huge rotating O'Neill cylinder to take us to Mars. And I don't know about you, but I don't have that.
No, I wish.
So we have to do these engineering slash medicine trade-offs, and to finally get the architecture for us that is acceptable risk for everyone to sign off and say, hey, this is like almost like an ethically approved space flight for us.
That's a good
And
question.
I think a lot of those trade-offs, whether it's muscle, whether it's bone. I can't wait to hopefully be in those rooms where those decisions get made. But it feels very, um, I don't know, it feels like there's so many inner layers to NASA, inner layers to research and stuff like that, that I don't know when or how or that's going to all happen. I think I know some of the players now. And part of
Yeah.
this podcast is to kind of get to know people and know the landscape a little bit better. But yeah, what a fascinating thing. If we end up needing two-thirds gravity for muscle, but bone is not maintained, but we say that this is acceptable enough.
Right, right. What is like good enough is such a big question that I'm always thinking about.
Yeah, I really will be curious to see. I'm so happy you brought up VAST. They just tested their hardware. It really feels like they're putting rubber to the road and they're ready to send it up. And I still think it'll be like 6 months to a year or maybe even more than that. But it really feels like, in terms of space flight, that they're moving really fast.
They really are. I thought it was just me that felt like Vast is moving really, really fast, like impressively so. So I'm, personally very excited to see how they continue to innovate and keep, like you said, they're putting metal to the pedal, pedal to the metal.
Yeah, rubber to the road, whatever
Yeah,
analogy
yeah.
you want. It's all good.
They're really just, pushing ahead. I think I remember they put out recently with SpaceX a solicitation for payloads. I think due in the next month or so. I think that's for their Haven One flight, so within the next year or so, which is fantastic. We'll see if I submit anything. I don't know.
Yeah, I've taken a look at it myself. One of the things that I was really interested in learning at the HRP IWS conference was the non-invasive ultrasound-based measurement of bone density. So, for all the listeners, we're both bone nerds. We both like, tune out if you're not interested in trabecular microstructure.
Yeah,
If that turns you off, then I don't know. Come over to the dark side one of these days.
yeah, they'll
Um,
see the light eventually.
yeah. But essentially, the technology that was recently brought to light was that you can use your favorite old trusty ultrasound in the emergency department or on the floor, and you can, with some software, you can essentially figure out if the bone, the reflected ultrasound wave off of the interface between bone, which is like a hyperechoic type of structure, whether that signal, whether the bone behind it is good or bad, essentially.
Wow.
And so it's not a great measurement because you're not looking at all of the microstructure and kind of all of the structure itself. But essentially, it's been validated in thousands of patients in Italy, is where the company is. And so I'm hopeful that they eventually fly that device because you don't have to use an X-ray, you don't have to, it's very portable, it's like the size of a suitcase, that kind of thing. So
Wow,
that was
wow.
my biggest takeaway from the conference is that this little suitcase device hopefully will be the next kind of ultrasound thing for us bone nerds.
Yeah, yeah, that is so cool. I didn't know that. I must have missed that one. Um, yeah, yeah. I think a lot about, what is going back to that conversation of like what is good enough, what is acceptable, you know, hazards to health. And then also like what do the astronauts think? Like, is informed consent, quote unquote, enough? Like if, we don't stop people from going skydiving, for example, right? Or scuba diving, where there are like very significant known hazards to health. So is being an astronaut like in that same bucket then? Um, I don't know. I don't know who
Well, if
makes
you're
it.
interested in those types of questions, I think it was like 2 weeks ago, I had a an off-camera kind of meeting with the first ever Johnson Space Center bioethicist.
Oh,
So they have a trained bioethicist. I think he's no
yeah.
longer officially the JSC bioethicist, and someone else is performing his role, but he's still very involved.
Mhm.
His name's Dr. Wolp, WOLP, and he's currently at Emory, which is where I'm at right
Oh
now.
yeah. Yeah. Nice.
And
Nice.
yeah, so I didn't know that like a person like that existed. I've
Yeah,
tried to
neither did
study
I.
the landscape for like almost like over 10 years now, and I'm still meeting new people. And yeah, so those types of questions he's very interested in, and is hopefully something that I didn't see any ethics papers at IWS. I
Yeah.
only saw one on like the IRB for JSC.
Mhm.
So hopefully, if you're interested, maybe we could collaborate on an ethics paper in the future.
Oh my gosh, that'd be so cool. That'd be so cool. Absolutely. Just thinking about these questions and like I don't know, who is designing like mission architecture, right? Are astronauts in the room when they're thinking about like mission operations, for example, or architecture for future campaigns? Um, I don't know. There's it's such a small field because it's so niche, but it's so big in terms of, right? It spans biology and engineering and architecture planning, environmental sustainability. It's one of those things where, I really do tell people space is for everybody. We need every single profession, every single industry within the space context. So it makes me hopeful that like people will continue to get interested and stay interested in the field.
Yeah, yeah, I'm super hopeful too, and I'm just just trying to understand that everyday people are connected to this, and that we if we want this awesome, amazing future of Star Trek, we need people, like we need more people to get involved, no matter what, whether it's science, whether it's art, technology, whatever it is. But yeah, I just it can't be overstated that like people feel like you can't be involved. It's like just try and ask people, like figure it out. Like if you're really interested, like there's a place for you somewhere.
Yeah, absolutely. I also like, I love, I've talked a lot with like younger students who are in like high school or undergrad. They're always asking, like, hey, I'm having a tough time finding opportunities like at NASA. And it's like we said in the beginning, it doesn't have to be NASA proper, right? You can work with universities to do research in the field. You can work with space societies like ASGSR, which is the American Society for Gravitational and Space Research. We have like a student program and student opportunities, or the Aerospace Medical Association has student branches and student organizations. But I also love telling people, or, not telling, I guess, because they can do what they want, but, suggesting that they can always,
You're telling.
no, um, about like creating your own opportunities, like I've spoken with high school students who also have started podcasts in this field, but not necessarily about space medicine, but more so highlighting, for example, all of the non-rocket science ways of working in the field, to highlight these different opportunities that are available. Or they'll make like infographics and flyers and newsletters for people to learn about what's happening in the field. Um, a lot of those like self-motivated, self-starter projects are so, I don't know, inspiring to me because I think to myself, like, wow, like this is a field that you have found. You are so passionate about it, just like the rest of us, that you're going out there and creating something new, right? Not just joining something existing, but creating something new from scratch is exponentially more time and energy. And I really admire that.
Yeah, I mean that just warms my heart that there's high school students and other students that you've worked with that are trying to create, that are out there just trying to make your own opportunities. I mean, that's these people are at, universities or at NASA. They have emails. They need help doing some of their work. It's a problem, like, getting paid to do some of that work a lot of the time. But I really feel like there's the opportunity is there. You have to look for it and you have to be, nice, agreeable, like you want to like support their mission and don't be too excited that you're, crazy. You have to be like appropriate and all that. But usually if you're like a relatively, easygoing person, they love that you can bring your skills to their field as well.
I agree. I mean, I got my first NASA internship by like emailing everyone I could find at NASA. I would Google like NASA space biology, NASA biology, NASA medicine, and just every single email I could find, I was like emailing them, hey, do you have an internship? Like, do you have any projects that I can work on? Um, and then eventually I found someone at Johnson Space Center who was like, oh yeah, I could use an intern. And so he made an internship, thing in the portal that I then applied to. And that's how it happened, right? It wasn't me just sitting down, submitting an application, hoping to get selected, but really going out there trying to connect with people who could actually use my skill set, for example, I think is 100% what made the difference.
And so what did you end up doing? Like tell me a little bit about
Oh,
that.
yeah, yeah. So that internship with Johnson Space Center, it was remote because of COVID, unfortunately. I think a lot of their internships were remote that year, but I was mostly looking at, I was within the radiation biology division, looking at the synergistic interaction between microgravity and radiation and how that affects immune health. Because we know a lot about how microgravity, right, affects immune health. We have a lot of data on how radiation, especially like galactic cosmic radiation, can affect immune
Such a
health.
cool word.
Right? I feel so cool every time I say it or every time I put it on a poster. I'm like, wow, yes, I am a space person. But we know a lot about how spaceflight stressors like these can individually affect the immune system, but a lot of studies didn't look at the combined effects. So I was doing this really big sort of literature review going through spaceflight analog studies, basically looking at either cell data or rodent data to look at the very few studies that looked at microgravity alone, radiation alone, and then in combination. And does that combination have a different effect than each of them alone? And what was really interesting was that in some cases, for example, they'd have opposite effects. And so the combined microgravity plus radiation wasn't too bad. Whereas in other cases, microgravity, for example, in this one study, I remember microgravity did not increase the level of TNF alpha, so a common immune like stress marker. Um, Microgravity didn't increase its level, radiation didn't increase its level, but you see this like, yeah, I don't know, I want to say like 10 to 100 fold increase from the combined microgravity plus radiation environment. And that's something we would miss, right? If we're not doing these multi-hazard studies, we wouldn't know how bad it would be unless we're more sort of thoroughly studying or recapitulating the spaceflight environment in our studies. Um, so I also think a lot about like multi-hazard or multi-stressor design for experiments because I feel like that's the way to more accurately mimic the spaceflight environment here on Earth for our science.
Yeah, that's I was definitely not aware of that.
Yeah,
That's I
crazy
think I've
stuff.
yeah, yeah, it's very, very interesting. I don't think I knew that microgravity and radiation would potentially be like offsetting in a way. That's
Yeah, yeah. There
I
were
don't-
definitely some that had like I divided them into like additive interactions, right? Or antagonistic where they have offsetting effects or synergistic where, you know, microgravity and radiation alone are sort of fine, but in combination they were like significantly worse um, for whatever was being studied. So it was interesting. I could find examples for all three of those buckets, which I did not expect.
hmm. Yeah, because like bone and muscle, they're like, both negatively affected and like that makes sense. But yeah, that's super interesting. And was this, I think you published a paper like on July 20th and you
Yes,
posted,
yes, it
yeah,
was.
yeah,
I was so happy it got published that day.
yeah.
That was that paper. Yeah, yeah, and
Yeah, the
immunity.
anniversary of the moon landing, you get your paper and that's super cool.
My first author paper on a space flight, topic on the moon landing anniversary. Oh my God, my mind. Oh yeah,
Icing on icing on icing on the cake.
exactly, exactly. Plus a little cherry.
Yeah. Yeah, that's so cool. I mean, talk about like being a go-getter, being so interested that you finally you landed that internship. Then you at some point started at Harvard, MIT, and you'd worked with Dr. Mary Buckstein. And so can you tell me about like, how you got into that lab, like as a med student, how do I get into research?
Yeah, yeah, it's tough. So I think because I'm in an MD PhD program, like I came in knowing I want to do a deep dive in research. I want to get the skills to, develop research questions, investigate hypotheses, um, really hone in on those kind of techniques that I'll need for the future. Because I think spaceflight is so research oriented because we don't yet have, that many patients to take care of. So the research side is very, very big. And I wanted to do a deep dive into that, which is what motivated the MD PhD as opposed to, an MD alone. Um, and so when you come in, you're tasked basically with rotating in several different labs to sort of try out different advisors, try out different topics, different labs, different techniques, and see what clicks with you. And so when I first started, I rotated with Seward Rutko, who is in neurology. He does a lot of neuromuscular research. Um, had a fantastic time in his lab. We studied, again, partial gravity in rodents, but this time looking at like sex associated differences between males and females. Would partial gravity affect them differently? Would hormones, addition or removal affect them differently? And then from working with him, I got in touch with Mary Boxine, who studies bone loss, and that's how I became sort of a bonehead. Um, and I think a really useful thing was leveraging, you start out with one PI, right? My first PI was Seward, and then leveraging his connections and his suggestions of, hey, who's another advisor, who's another supervisor that I should reach out to? And he knew Mary, so I got in touch with Mary and had a fantastic time again on the MH28 project, my first spaceflight mission. And then from talking to Mary, I was like, hey, who's another supervisor that I should do a rotation with? And so then I got in touch and rotated with Mark Wine, who does more like osteocyte gene expression analysis at MGH. And so that's who, in conjunction with, we did a lot of the gene expression analysis for ME2A. And then from there, I was like, hey, like, who are other people that I should talk to? And then I rotated with Lonnie Peterson at MIT. And she's not a bonehead, right? She does like fluid shifts in microgravity and how can we engineer countermeasures to help keep the cardiovascular or the neurological system um, safe and healthy in space. And I had a fantastic time there. And, now I'm working in her lab for my PhD. And so I think it's also helpful because the PI will know who's a good mentor and who's not, right? You're not going into it blind. They've been vetted a little bit, and I think that makes that whole process a little bit easier for sure.
Yeah, I mean, getting that kind of insider knowledge on who's a good PI publication wise, who's a good
Yeah.
PI mentorship wise,
Oh, good
and
differentiate.
who's a PI that will have your back. Because sometimes they can be, the person can have only one of those
Yeah,
things.
yeah, they might not be the same person, and I think it's important to have all three of those people, um, if hopefully overlapping.
Yeah.
Yeah.
So actually, I don't know exactly where you are in your journey. So typically in the US, MD PhD is 2 years, and then 4 years, and then 2 years. So 2 years of medical school, 4 years, or maybe sometimes three if you're super duper lucky,
I
which I
don't
hope you
know.
are. I don't I don't know, but at where in the stage are you?
Yeah, so I'm a third year MD PhD student, so that means I guess I'm finishing up my first year of grad school now, um, in a couple months. God, it feels like time has flown by. I can't even, where has the time gone? Yeah, so the way my department works specifically is that they want us to pick up a master's along the way. So I probably won't be a 3 year in and out type of person. But I'm super excited to be doing this kind of deep dive into questions that I'm really passionate about. So I think I'm thriving, in grad school. It's been a fantastic transition for sure.
That is, oh my God, that makes me so happy that there's MD PhD is super tough and super hard, um, for reasons that are expected, and then there's all the reasons that are unexpected. And finding the light, or finding the carrot at the end of the stick to keep you going, and to have that light is just, it's super nice and refreshing to hear. And I just, your work at these conferences that I've seen you at is just amazing, and I can hope you continue to kind of do all this awesome stuff. So
Hopefully,
you've
fingers
now
crossed.
what's that?
I said fingers crossed.
Yeah. Well, you're at least in the right circles, and have made, at least for me, like on the outside looking in, have made a name for yourself in the bone world. So just can't wait to see what you do next in Dr. Peterson's lab. So is there anything that you're like, ooh, really excited to test, or like, oh, we
Yeah,
have this
yeah.
technology that I'm looking forward to?
It's definitely a transition for me from being a bonehead to, I guess, a brain person. I don't know if we have a funny I don't know if we have a nice catchphrase like brain heads. That's not
Yeah,
it doesn't flow as nicely as bonehead, but I'll workshop that. Um, yeah, I'm really interested in looking more into the fluid shifts that happen in microgravity, right? Because the way I explain it to people is, on Earth, all of our fluids are being pulled down because of gravity, right? Our blood, our other fluids in our general milieu. But in space, that isn't the case. All of that is sort of more equally distributed because of the lack thereof of gravity. And so astronauts will end up with like puffy faces or puffy arms, or that increased pressure from all that fluid in their head can push on their eyes and change their brain structure. It can change their vision. um, so I'm really interested in understanding more about how that happens, why that happens, how can we prevent it. um, One thing that I knew coming into my PhD that I really want to study or want to focus on is I'm really interested in looking at one question through a variety of modalities as opposed to using one technique to study many questions. So for example, I want to study this brain project, this brains in space topic from like cell culture using like brain organoids to rodents using like hind limb unloading, for example, to people using clinical trials, head down tilt bed rest studies, and understand this translational spectrum of what's going on. And sort of keeping in theme with partial gravity, we have something called a random positioning machine, an RPM. And it's basically this two-frame machine that will turn a sample in the middle through the different axes over time. And we've shown that that can actually simulate weightlessness. It can simulate microgravity at the center of rotation because over time, a sample will experience the gravity vector in all different directions. And so I'm really interested in using that as a platform, for example, for the brain organoids, putting them in an RPM, seeing what happens to them, and then using that RPM as a partial gravity simulator. So no longer zero gravity, but maybe I program it to spend a little bit more time in the down position. Maybe, for example, one third, and then I can mimic one third gravity, and then two third, and then we'll have ground, regular controls for 1G. And again, building up this dose response profile of what's happening to the brain in space, how can we prevent it? Can we give them maybe some medications to help prevent those damages that we see? Um, Trying to understand sort of the cellular and molecular mechanisms behind these, and then use that to guide translational studies with rodents and people further down the line. Let's see.
So that is so cool. I've heard about random positioning machines, RPMs. I have a practical question for you. So I used to culture like adherent cells, some cells in suspension. So for an RPM, do the cells have to be in solution, like in suspension? So these organoids are just kind of floating around. Is that
Yeah,
the kind of idea?
I would my gut would say that yes, they should be in suspension. So these organoids are like free floating, they're spherical, they're not like 2D, which I think is what really lends them well to a project with the RPM. Um, Whereas, things like osteocytes, for example, which are more contact driven, for example, um, you could also put them in an RPM to see what happens, but I don't know if it would be as, I don't know, informative.
Yeah, I don't think it works, right? Like it doesn't, the
I
actual
think
random
they don't
positioning
like,
does not provide a gravity vector that
yeah,
makes
I don't
sense,
think
right?
they make their like little projections when they're put into an RPM. Um, I think that's probably stunted because of that.
Interesting. Yeah. I mean, I, so these organoids, are, like, what is the, like, are these tissues like the shear stress on the tissue, like, from a bone sense makes sense. Like that's like how osteocytes like feel and do all their stuff. But is that kind of fluid shift or fluid shear around the interface of the organoid, like is that is that a physiologically relevant thing? Like how does like I don't I get like I'm trying to figure out like fluid shift brain organoid. Okay, I get the connection. I'm trying to like connect the dot one more of like, okay, so you physically have a brain organoid in this machine. Is it How exactly is it feeling the negative gravity or like
Oh,
the lack of gravity? Because
I
it
don't,
is experiencing like fluid
yeah.
shifts around it in the culture media, right?
Yeah, I mean, there would be fluid shifts and like those kind of shear forces. The goal in this context is to minimize that because that can end up like perturbing the sample in ways that wouldn't be perturbed in spaceflight. So, for example, like they wouldn't have shear forces if they were in solution on the space station, for example, the organoids.
Yeah.
Uh, so, our goal is to understand Like when it's less about like the mechano sensation and more about, for example, previous studies with brain organoids on the space station have found that there are markers for accelerated aging or like increased immune activity or increased cell death, all, sort of hallmarks of aging in disease or like in neurodegenerative diseases, for example.
Hmm.
Um, and so we're trying to see if we put those brain organoids on an RPM, can we recapitulate those findings? And if so, we can validate the RPM and then use it for partial gravity studies, which we can't do. Um, and so I think building up that profile of what are those kind of biomarker, those cellular biomarkers, how are they changing in the gravitational states will be really
Hmm.
interesting. But I'm not sure about mechanosensation, mechanotransduction within the brain itself. That would be really interesting, though, a bone
Yeah.
crystal on the brain.
Yeah. Um, yeah, I think your approach and your enthusiasm for that kind of multi-picture snapshot of the same problem is just it's so well suited for space flight because it's like you have one tissue, like in some of these experiments, you have one
Yeah,
rodent, and it's like, okay, how are we going to look at it from every angle? So maybe part of like that history you've had is bleeding over to now you're present and influencing that kind of thought process.
it's wild to look back every now and then and be like, wow, I am really pulling from every single experience that I've had in the past, even if I felt that experience was just like for fun or like kind of useless, but I wanted to do it, so I did it. Like I did a math minor, for example, and I learned a lot about Python and computational neuroscience because of it. And now I'm using like programming skills, and I need that in my day to day to take my classes and to do my research, and to build these kind of models, for example. And so, it kind of blows me away that, like, wow, everything is sort of finding its place along the journey, um, which I didn't expect. It's nice.
Yeah, I had one mentor who said, don't worry so much about connecting the dots forward, connect them backwards. And what this person meant was we always want to be so anxiety driven about all the steps about how we're going to get to that career that you mentioned at the very beginning of 20, 30 years from now, you have a med student come up and is really excited that you changed their life.
Yeah.
And we really want that. We really want to, make new innovations. We want to help people get to the moon and Mars and stay. We want to tackle these interesting questions of, human physiology of just can we survive in different forms of gravity? But to get there, you have to let this organic process kind of permeate and take you to places that you didn't expect. And then when you look backward, this person was just like, yeah, it'll make sense. I swear to you, it'll make sense to you, and it'll all proceed logically, but just focus on the next step and then look behind you and say, oh, okay.
Yeah.
And just keep going. And you'll find, and if you're interested and you're motivated, just keep going and you'll find
Yeah.
yourself in crazy places.
Absolutely. Keep going, keep exploring new skills, learning new things. Don't shoehorn yourself is a really big thing that I keep trying to tell myself. Um, I've started learning, or I'm trying to learn how to 3D print things with, CAD and like computer aided design software. Oh my God, I'm a biologist. Why am I doing this stuff? This is not for me. Uh, Biologists were never meant to use computers.
I'm sorry, I'm laughing at your pain. I'm sorry.
It's
Hopefully it's cathartic to laugh, it's like, oh my, it didn't, the material didn't adhere correctly, the temperature was off.
I'm like, why am I getting myself into this? But it's cool, I'm learning a new skill. I'm technically in an aerospace engineering department. I was like, you know what? I might as well actually pretend to be an engineer then and learn some CAD, learn some 3D printing. Just picking up new skills, I think, is good for your brain, good to always be a learner, but also good to just expand your actual skill set of like what you have to draw on for sure.
Yeah, that's really, just hats off to you. I mean, sticking within biology and medicine is already so multifaceted in terms of, things that you can bring to it, like coding skills, um, physics, math that you mentioned. Like there's so many things that you bring to medicine, and then um, switching into or like having the opportunity to be in the aeronautics department, engineering department is, and like really diving into that, like that's a lot. That is a lot.
Yeah, yeah. I think it makes me a better scientist though, because, when I'm designing or when I'm talking, for example, to engineers who are working on, for example, products like medical products or biological, biomedical research, um, I can actually talk intelligently about the biology. Or when talking to biologists about something, a product that they would like to see, I can talk not intelligently, but I can talk a little bit about the engineering that might go into that or what that might look like to actually be feasible. Um, and so I think it really like I think both of them really complement my skill set and complement my sort of understanding of science, of research. And so I'm really glad that I've been able to sort of straddle both fields um, in so much as I've been able to so far.
Yeah, that's just hats off. That's crazy. Yeah, I feel like learning code and having a math background and all of that is it can mean something on paper, but you're bringing it to life, and that's like a really cool aspect. And I think that it kind of goes to show back to another point that we had. People with math backgrounds, like we need you in medicine, we need you in
Yeah.
space medicine, we need you to help us do all this kind of awesome and cool work that we hopefully will be able to do.
So if you like math, if you're listening, if you like math, don't just consider rocket science and orbital trajectory and stuff like that. We need you in medicine too, please.
Hmm. Yeah, I think so. SpaceX and UCLA have a emergency medicine fellowship in space medicine. So after you do med school, after you do residency emergency medicine, you do another thing called fellowship, at least in the United States. And one option that you can do is a space medicine fellowship where they super highly desire perhaps a person like yourself with both a medicine background and a engineering background because they really want to um, have people who can speak both and that can help literally design the spacecraft that will take people to the moon and Mars.
Wouldn't that
So
be
it kind of
cool?
brings me to another. What's up?
That would be such a cool job title to have, spacecraft designer. Like, wow. Yeah.
Yeah, I mean, you're doing the right things to get there. But it brings me to another question about the future. For you, you talked a little bit about where you came from, how you got involved, what you've been doing lately in both the labs of Dr. Buckstein and Dr. Peterson. You're in your third year.
Mhm.
But where do you see yourself in like doing residency? Like what specialty?
Oh
Like
my gosh.
have you thought about that? Like it doesn't really matter at this point, but just
So,
kind of curious,
yeah.
like where, if you were to ever look back at this video and not cringe too much,
On hearing my own
oh, like
voice.
what do you think you'll be in like for residency?
Yeah, good question. I think it again goes back to okay, the short answer is I don't know. The long answer is again, space needs physicians of all specialties. And so I've really tried not to shoehorn myself into anything specifically. Like I love bones, and so I was thinking about orthopedic surgery for a while. And then, I really love like women's health and reproductive justice is something I'm really passionate about. So I was considering OBGYN for a while. Right now, I'm super obsessed with emergency medicine. I love the shift schedule. I love the idea of being an independent physician in the sense of, if you're a surgeon, you're reliant on a hospital, on anesthesia, on having an OR, et cetera. But the idea of like, with a bag of supplies in my like car trunk, I can pull over at the scene of an accident and like see if there's anything that I can help with. Or, if they raise their hand or, they're asking for a doctor on board in the middle of a flight, like I can raise my hand and like be someone who helps in those kind of scenarios. I want to be that resource for people when like they're looking around and they need help. I want to be that help. And so I'm really, really excited about emergency medicine, but we'll see. Maybe that'll shift, right? I still have my medical rotations in third and fourth year to go through. Maybe something will again like speak super passionately to me the way space medicine did. Um, I don't know. I don't know yet. Right now it's emergency medicine, but I'm keeping all my doors open for as long as I can. And
Hmm.
then after that, I definitely want to do a space medicine fellowship, whether that's, the one at UCLA, for example. MGH also has a space medicine fellowship after emergency medicine. There's the one over in UTMB for aerospace medicine, which isn't necessarily post-emergency medicine. You can do it after almost any specialty, actually, which is really attractive as someone who likes to keep her options open.
Hmm.
Um, Hence the MD and the PhD, I guess. But after that, I don't know. I'm open to like being a professor and running like a space physiology lab. I'm open to being a flight surgeon and working at NASA or working at SpaceX or VAST, working with astronauts, making sure they're healthy for missions, making sure they're healthy and safe during missions, being someone who helps design spacecrafts to ensure astronaut health and safety and performance. Um, the cool thing is there's so many different ways to put space medicine into practice. And I'm hoping that those opportunities just continue to expand, continue to grow. I just want to do cool stuff and we'll see where that takes me.
Yeah, I'm sure it'll take you you're on such a great path and you're already, in the right rooms doing some great research and it's been so lovely to talk to you and get to know
Yeah,
you
thank
and meet you a
you.
little bit more than just asking a question at one of your talks.
Oh yeah.
Just getting to know the whole person that you are, and getting to kind of just understand your perspective and on the field that we both like kind of are entering in and finding our way and trying to build a little bit of a community of people where we can say, hey, like we're not so alone. Like we're not space
Yeah.
medicine is people like it other than just me.
Yeah, I had someone ask me, I told them what I do for research. I'm like, I research, space medicine. This is what it is. And they're like, okay, is that a real field or is it just you who does that? And I'm like, no, no, it's like, it's real. I go to conferences. There's other people out there who study this. It's a real thing. I absolutely love what you're doing with the Let's Talk Space Medicine initiative, whether that's, the Twitter newsletters or the podcast helping get the word out, I think is just so, so important for our field.
Yeah, I mean, thank you. It's one of those things that's like the self-generated kind of energy where I just kind of got tired of sitting around and waiting for a community to evolve out of space medicine because you're in Boston, I assume, like I'm in Atlanta now, like there's people and investigators all over the country and the world that do this, but there's not like a connection. Like people usually go back home to their own university and then they're kind of in their silo where, maybe at a place like Harvard and MIT that there's, maybe there's more than a handful of you that are interested in space medicine. But some of these institutions, you're the only person or you're one of only a couple.
Yeah.
So the whole point is to kind of bring us together through the internet. I mean, we've been in the internet age for forever. Like let's connect.
Yeah,
let's try and do some discussion and meet all the great people that are doing work in this field.
absolutely. Absolutely. I resonate with that so strongly. I mean, even here, there's, I would say, not that many of us for here being Boston, like not that many of us doing space medicine, and we're all spread out across Harvard, across MIT, across all the different hospitals. People at Tufts, for example, like we're BU, like we're all in this very small geographic region, and yet we're not doing a very good job of connecting and building that community, building that sense of, this is what's happening in the field. So I definitely think that's something to continue working towards for us, for sure.
Yeah, just I think about, back to the beginning of the conversation where this one person influenced your life. Like, what if, at least in my case, like I found a degree program at King's College that has like space physiology. And I just was like, what is that even?
Yeah,
And that was like finding that web page was it for me. And that kind of
yeah.
everything has kind of proceeded since
Oh
then.
my gosh. Oh my gosh.
And
Yeah.
so I mean, but it's so good. It's so cool. It's really awesome, incredible work, but it has an advertising and a PR problem. Like either
Yeah.
people at NASA or don't want to, expose it, or like maybe there's not enough opportunity in their eyes where there's only a limited number of space medicine positions, for people that take care of in the clinical setting, astronauts pre, during, and post flight, the flight surgeons.
Right.
But I feel like there's a whole host of other people that if they had just a surge of people to help the medical capability, that it would be who doesn't want that? Like,
Agreed.
why aren't we trying to get more people interested? Like, what is there? There shouldn't be really any pushback on trying to build excitement for the field that you're in, right?
Yeah, you're right. We do have a PR problem. Yeah. We need to get we need to get some influencers on board, like help them advertise what we do. Something like that. I don't know.
My like the my like I guess in one of my inspirations is someone you may be familiar with. His name is Tim Dodd, the everyday astronaut guy. He does rocket
Yeah,
videos. So
yeah.
essentially, we need someone like that for space medicine. Someone
Agreed.
who can popularize it, someone who can really get people interested, describe interesting problems, and say, help essentially give people a reason to be like, maybe I should know about this field. And yeah, it's pretty cool.
Yeah.
And
Yeah.
maybe they'll contribute it to it in a way that isn't directly medicine or directly engineering. And I want that at least, and it sounds like you do too. Um, but yeah, we really need, I mean, I would really hope that we should be growing the field. Anything to grow the field is good.
Yeah. I agree. I agree completely. We're probably both preaching to the choir here, you
Yeah.
know.
Yeah, who's gonna, watch this podcast? Who's gonna, stumble across it and then be like, oh, I got to minute, almost an hour in and oh yeah, I really,
Yeah,
really
they
gonna
started talking about wanting more people in their field,
yeah.
so that's when I had to turn it off.
Well, this has been amazing. I kind of wanted to close with maybe some of your, far future predictions, some of your, or maybe I think you gave a talk with Dr. Zubrin. Is that right?
Yeah, yeah, at the Mars Society.
Yeah. So I interacted with him maybe once or twice on Twitter or X.
Hmm.
And it seemed like, and I don't know if this is true, but it seemed to be pretty like negative towards spaceflight research.
Yeah.
Because he was like, you're sending people up, you're making them sick, like you're not doing all these countermeasures.
Hmm.
And I could be misremembering it, and I don't, it was, I think, over a year or two ago. But I'm kind of curious, like, how was meeting him, and that whole experience, and then maybe like your predictions. Then
Yeah,
we have
yeah,
about half an hour left,
yeah.
and we'll wrap up after that.
Cool. Okay. So the Mars Society was it was really interesting how that happened. You know, every now and then I'll post my science on Twitter. I'll be like, this is what I'm doing. This is, went to this conference. I met Kyle. Um, and one of the posts, I guess someone like retweeted it and it kind of blew up. And then Dr. Zubrin saw it on Twitter and basically um, messaged me and was like, "Hey, do you want to give a talk at the Mars Society on your research?" And I was like, yeah, I do. Uh,
Yeah, where do I sign?
I'll be there." um, so yeah, that was in Seattle. I want to say last August, I think it was. And so I gave a talk on the MA28 project talking about, again, artificial gravity as a countermeasure for bone loss in space. And I really ended with like, what does this mean for going back to our discussion of like different stakeholders involved, who's making those decisions, just kind of open-ended questions and food for thought. I think what was really interesting from both Dr. Zibrin and, the Mars Society, attendees was like, I don't know, I hesitate to say negative, but maybe frustration with the spaceflight research in the sense that, I do hear some of their concerns in the sense that, we do have a slower cadence to our research, given that, especially for spaceflight missions, they can be few and far between. We can struggle with like sample sizes because it's so hard to send, for example, a lot of animals or a lot of cells to space because that costs a lot of money still. Um, and so the progress can be slow, but I think the progress that we're doing is still so, so important. Like, we don't want to cut corners because the second we start cutting corners, right, astronaut health is at risk. And that's not something that at least I'm personally willing to risk. Um, Maybe if you talk to other people, they might be, or they might say, like, hey, astronauts know what they're signing up for. That's their prerogative. Okay, but that doesn't mean we have to make it unsafe for them. I think we should still be doing our best to think through things, approach things thoughtfully, approach things carefully, humanely, ethically, etc. Um, and so I think that's sort of more of the concerns that I heard. There's also two big camps that I think people fall into, which is either Moon to Mars or Mars Direct.
Yeah.
Um,
I wonder which one Zubrin was.
yeah,
He
yeah,
wrote a book called The Mars
Mars.
Direct Plan, or so. I did read that book and I did enjoy it. Thought it was
Yeah,
an
okay. I
interesting
have not
perspective.
read it yet, but it's on my list. I'll check it out now that you've recommended it. Yeah, I think people either fall into Moon to Mars, right? Going to the moon, using that as like this test bed for technology demonstrations, for proof of concepts, etc. Um, versus Mars, before going to Mars, versus Mars Direct is just saying, hey, let's skip that. Sorry, I think my doorbell was ringing. Um, Versus Mars Direct, which is going straight to Mars, using that directly as a technology platform almost. But then it's not even like a platform. For me, it's like I I worry about validating all of our technology, validating our systems before we get somewhere to Mars, which is, a 3-year mission versus the moon, which can happen at a much shorter cadence. Um, so I worry about that from a safety perspective. I worry about it um, from like a technology perspective. Like, we don't have the space, for example, on a moon or a Mars mission to have some of like the exercise countermeasures that astronauts are used to. So, okay, what do we do in its place? We don't have anything that's good enough. Um, and I think we need more time to develop that. I also think maybe this is more marketing, but I feel like going to the moon, what I've read and what I've heard, I don't know too much about it, but what I've read is that going to going to Mars after going to the moon is like much more expensive and harder because of like gravity wells, again, I'm not an engineer. I might totally be butchering this. But because of that, it'd be way more expensive. But my thought is like, if we go to the moon, I think that would galvanize people and get people really excited about space again. And then public funding, public perception, congressional funding hopefully will follow that. And then, provide enough sort of cash flow to make going to Mars easier or more feasible. Um, I don't know anything that much about money though either. So maybe I'm just totally up. But that's like sort of what my gut instinct is telling me that like we get this lower hanging fruit of the moon, which is also super cool, use that to, galvanize people towards an even bigger fruit or an even bigger basket to go after next. But we'll see.
Yeah,
What do you
we will definitely see. I I can see both points,
yeah.
and just for that, we could have a whole nother podcast to talk
Oh.
about this. But essentially, the Mars Direct kind of retort to a lot of that is, well, the technology developed for the moon maybe doesn't apply to Mars.
Yeah.
And, if we're going to develop, if it's so hard for us to develop one option, might as well do it for the better option for us long term.
Yeah. Like I can totally hear that and I get it, and I agree with that too. So I'm like, maybe
Me too.
that'll
Me too.
and I don't know.
Yeah.
I don't know if there's a right or a wrong answer, really.
Well, right now it feels like we're doing both in a way because we have the congressionally funded, Artemis program aimed at the moon, going there. And then with the help of private companies, SpaceX, Blue Origin, helping the moon program, developing those in lunar orbit and on the surface of the moon. And then they're also internally so geared towards Mars. So
Yeah,
it is kind of a multi-pronged approach,
I agree.
and using different pools of money based on who's holding the purse strings. So
Yeah.
it feels like we're kind of doing both, and it doesn't have to be an all or none. So it doesn't have to be all moon, all Mars.
Mhm.
Um, it's through the advent of commercial space flight that we actually have more options, which allows more people to be doing more stuff.
I can completely change the game. Absolutely. Yeah.
Yes, I think that I would say if I had to choose, if gun to my head type of thing, I would say that we should do, we should probably go to the moon first.
Mhm.
Because I think
Yeah.
I'm engrossed in the literature that's telling me how potentially irreversible health changes would happen to an astronaut on a mission architecture to Mars. So
Okay.
if I didn't know that and I just said, oh, well, you just go to space and you float for a while and maybe your eyesight gets a little worse,
Yeah.
but that's not it. Like
Yeah.
there are serious, as you mentioned, like ethical hurdles and acceptances of risks that of going to Mars that I don't feel comfortable doing.
Yeah. I think until we have better countermeasure development, better understanding of what's going to happen, I, yeah, I also wonder like, you wouldn't have a surgeon do a procedure that like a patient wants to get done if like they know it's going to irreversibly harm them, right? And they're just doing it because they think it'd be cool, I guess, or just doing it to do it. So I think we also have to be like very thoughtful about again those bioethicist questions that you were talking about. Um, I think are going to play a huge role in how we sort of um, develop this mission architecture. I
Yeah, well, I am interested in developing some of those research questions, ethics questions, so I would love to talk to you more about that.
Let's
It seems like it's kind of rattling around in your brain, and it's just so that it's
it's
up
never
here in
found an
my
outlet. I'm so glad that we're having this chat right now.
Yeah.
It's fun and
I recently read there's two books, Health Standards for Long Duration and Exploration Spaceflight and Safe Passage that I would recommend.
okay.
They are freely available on PubMed through the Institute of Medicine.
Okay.
And they are essentially the written word of the ethical standards for spaceflight. And if they're interesting, this is interesting to you at all, as well as to any listeners out there, like, please pick it up. It's so good.
Cool. Cool. I'll have to check that out for sure. Thank you.
Yeah. All right. Well, do you have any last kind of closing thoughts? It has been so nice to meet you.
Likewise. Yeah.
You're such a, nice, thoughtful, intellectual,
Thank
person. Your work is great. You're great. You're awesome. Continue doing what you do.
thank you.
And
Thank you.
I'll be watching from the other side of Twitter and cheering you on.
Yeah.
Okay.
Thank you. I appreciate that. You as well. I mean, I'm so glad that we had the opportunity to connect and chat and, host this together. This was super awesome. I guess I will also suggest a book. I'm reading the Red Mars series by Kim Stanley Robinson. Just finished book two. I'm on book three right now. Fantastic. It's a sci-fi book. It explores, what will happen with the first 100 people that get sent to Mars, how that
Only
might go.
good things.
Only good things. Yeah. There's no bad things at
And
all.
nothing happens between their clock cycle was like 24
Yeah,
hours and then the clock stops for 57 minutes or
something like
something like
that.
that.
Yeah. Nothing ever bad happens in that time. No.
Nothing bad happens and there's no political,
Everybody's
squabblings.
happy. Everybody agrees on things. Yeah.
Mhm. Yeah, it goes red Mars to wait, is it blue then green or green then
So
blue?
it's red and then green and then blue.
Okay. So yeah, the transitions, everyone survives. It's great.
Yeah.
Spoiler
Yeah.
alerts, everyone survives and nothing bad happens.
Yeah. Okay, fantastic. Thank you for having me again.
Yeah, such a nice time to meet with you, and yeah, definitely pick up the Mars trilogy. And I will definitely catch you at the next conference. I will make time for you,
Yes. Yes. We'll
because
coordinate.
part of this is to make space friends,
Yeah.
to be at a conference and have friends that you want to go see posters with, that you want to cheer on their talks. And that's kind of the point. So I will exchange information, and I'll definitely make a point to meet up with you at least at. Are you attending ASMA?
I want to so bad, but not this year. I'm hoping next year I can.
Have you attended in the past?
No, no, I haven't gone. I've only ever gone to ASGSR and HRP IWS that we talked about earlier, but I'm
Yeah.
hoping to wiggle into asthma eventually as well.
I'd be really curious to hear your thoughts on the differences because those are kind of the main three players, at least in my eyes, on
Yeah,
the from the
yeah, I agree.
biomedical research standpoint, and they all have different pros and cons. And it'd be great to see you at one of those in the future.
Absolutely. We will definitely connect and chat.
And with that, thanks for listening to Let's Talk Space Medicine. If you want to continue the discussion and meet more fellow space nerds, be sure to check out at Talk Space Med on Twitter and the Let's Talk Space Medicine server on Discord. Thanks and see you next orbit.